Hello, welcome to Collecting Like Terms Lesson 2. First of all, can you look at all of the terms that are on the screen in front of you? Pause the video and see if you can match up the terms that are like terms. Pause the video and see if you can note into your maths book groups of like terms. Okay, so hopefully you've grouped together the like terms, and this should have been your answer. So over here on the left-hand side, we have the terms that all involve x's. It doesn't matter that this one is negative 5x, it's still an amount of x's. So these are all like terms. These are all y's. Again, it doesn't matter that this is a decimal, it's still an amount of y. Here are all of the a's. These are all of the b's. These are like terms. And these are the constants. There is no variable involved here. And these are all like terms because they are all a constant. This is the odd one out on its own, 7xy. It has an x, but it isn't part of this group. It has a y, but it isn't part of this group. It's a separate type of term altogether, 7 multiplied by x multiplied by y. Okay, this is a true or false exercise. Can you play along? Pause the video if you need to have a bit of time to think about whether these are true or false. So first of all, 2x and 5 capital X, these are like terms, true or false. You should have decided that this is false, and that's because a capital X is a different variable to a small x. It could take a different value. It could be representing a different amount. Next, 4x and 4y. These are like terms, true or false. Pause the video if you need some time to think. So you should have decided that this is false. The coefficient is the same in both cases. We've got a 4, but the variable is different. So these are not like terms. Negative 3x and 5x. These are like terms, true or false. Pause the video if you need more time. So you should have decided that these are like terms. It doesn't matter that this is a negative 3x, it's still an amount of x's. These are like terms, 4 and 7, true or false. So you should have decided that this is true because they are both constants. There is no variable involved there at all. And finally, 6xy and 2x. These are like terms, true or false. So you should have decided that this is in fact false, because although this involves an x, it's 6 multiplied by x multiplied by y, and that is not the same as just an amount of x's. So these are not like terms. Okay, so now we have an example which is a little bit different from the ones we were doing last time, because we have got two different variables in the same sum. So I am drawing out a first row to represent my term 3x, then a second row to represent 5y, then 2y, and then 7x. So what I'm going to do here is collect together my like terms, and I'm actually going to move the 7x up so that it's on the end of the 3x, so that I've got one row of x's, and then I'm going to collect together the y's as well. So I've collected the 5y and the 2y together. And I can actually rewrite that calculation now so that it's describing what I've now got below. So I have 3x plus 7x in this first row, and then 5y plus 2y in this second row. And now I can sum what I've got. Look for any zero pairs first, but there aren't any here. And that gives me 10x plus 7y. And what mathematical law have we used here? We've used the commutative law because we've changed the order of this sum, knowing that it is still going to give us the same answer. Okay, this one is slightly different because we've got a negative amount of x's here. We've got a negative 2x. If you think you could already give this a go, pause the video, draw out counters and see if you can find the answer to this problem. If not, keep watching. So I have 7x first of all, and then my second row is going to be 3y. I'm adding to that another row of 4y, and then I have a negative 2x. So again, just like in the last example, I am going to collect together my like terms. So first of all, I'm collecting together the y's. Now, the 7x and the negative 2x, they are like terms, but to help me look for zero pairs, I'm going to put negatives beneath the row of positives. And now I can look for my zero pairs. I've reordered my calculation, so this sum here is reflecting what I've got down here now. So 7x add negative 2x, and then positive 3y add positive 4y. So I've used the commutative law. Now I can look for zero pairs, and then finally I can sum what's left. And I've got 5x add 7y. Now the direction belongs to the term has appeared at the bottom here, and that's just to remind you that this is actually a negative 2x. I can think of this as plus add negative 2x, and this has moved with the term because it is the direction of this term, which is why you can see it here in brackets. Okay, so this one right here, you should be able to give a go now. So pause the video and drawing out counters into your book, can you answer this question? Okay, so you should have drawn 4 negative y's, 5 positive x's, 2 positive y's, and 7 negative x's. And next, I'm going to collect together the like terms. But I'm going to keep the positives and the negatives in separate rows, although they're like terms, so that I can look for my zero pairs. So I'm going to move the negative x's to the top there and the negative y's to the bottom. So I've collected together my x's and my y's. This is my new calculation, which reflects what I've just done. So I have negative 7x, add positive 5y, add positive 2y, add negative 4y. Now I'm looking for zero pairs, and I have 5 zero pairs in the x section and 2 zero pairs in the y's. And now I can sum. And altogether I have negative 2x, add negative 2y. So negative 2x, subtract 2y. If you'd prefer, you can draw a bar model out to save you having to draw out lots of counters. So with the last example, I would have drawn out a bar to represent negative 4y, a bar for positive 5x, a bar for positive 2y, and a bar for negative 7x. Now you can see that the thickness of these bars is different to the x bars, and it doesn't really, this isn't 4/5 of this bar, and that's deliberate. It's not supposed to be, because y is representing something different, a different amount to x. And so I've tried to reflect that by making the bars look different. So I'm going to collect together my like terms, just like I did with the counters. I've taken the -7x to the top and the -4y to the bottom. The difference with the bar model is that I'm going to have to partition to find my zero pairs. So in the top, I'm going to partition this -7x into -5x and -2x. And on the bottom, I'm going to partition this -4y into a -2y and another -2y. And now I can look for my zero pairs. Got one there and one there, and then I can sum what remains. Okay, so in this exercise here, you have 7 questions that all look very, very, very similar, but are not going to give you the same answers because we've got different directions going on in each question. So what I'd like you to do is to pause the video and try and answer these by drawing out counters into your books, or bar models if you prefer. And whilst you're doing it, can you think about what is the same and what is different in each question? And then you can watch the video that goes through the answers to these, where we will then discuss what is the same and what is different.